I talked to you about neutron stars and black holes, but you may ask the question how neutron stars and black holes are produced. Actually, neutron stars and black holes are reborn stars. They are the stars which are reincarnation of the original massive star which underwent what is known as a supernova explosion. And about 200 such supernova have been detected in our galaxy, and almost every day you detect one or the other supernova in external galaxies. Okay, so neutron stars and black holes are supposed to be born from the reincarnation of dying stars, and we'll see it how they are born. And in the supernova remnants are also bright X sources, because what happens when the supernova undergoes explosion, then large outer layers of the star are thrown out at a huge velocity which could be as high as 10,000 to 20,000 kilometers per second, and this shock heated gas expands. Okay, this gas which is expanded in a form of a shell, it hits the interstellar medium and produces a gas which is at temperature of 10 to 6 to 10 to 8 Kelvin, and this gas becomes a powerful source of X-rays. So you find that the if it is a neutron star which is produced during the supernova explosion, then this neutron star becomes a source of X-rays, as you saw in this case of Crab Nebula. So how do you know that the neutron stars are produced in supernova? Because you find association of supernova remnants and neutron star. In fact, more than a dozen such associations are known, most famous being Crab Nebula, Vela, Pulsar, um, PPSA, and so on. Many such sources are there in our galaxy, at least about 12 to 15 sources we know very well. Next slide, please. So there is a this slide explains how the supernova undergoes massive star undergoes explosion, and how neutron stars and black holes are produced. So if you have a stellar nebula which becomes a star, collapses, evolves into a star. So if it is an average star, by average star I mean if the mass of the neutron star is less than or 8 times the mass of the sun, then it evolves into a red giant. In fact, our own sun will become a red giant at one stage and will up the earth, and probably the whole life will be extinguished. And then when as the red giant evolves, it sheds the gas and then it turns into what is known as a planetary nebula. Okay, and the red core of the star becomes a white dwarf, and the outer layers glow as a kind of a nebula which is known as a planetary nebula, and the center you have white dwarf. But if it is a new star is massive, its mass is more than 8 times the mass of the sun, then again as the star consumes its fuel and it evolves, it first exhausts hydrogen and then helium. Burning starts and helium gets converted into carbon, nitrogen, oxygen, and heavier elements are subsequently synthesized. Ultimately, the core becomes iron core. Everything gets converted into iron, and when it becomes iron, then iron is a very has very high is very stable element. Its binding energy is very large, and therefore you cannot generate further energy by thermonuclear reactions, and therefore the star is not able to support. There is not enough thermal pressure to counteract the galaxy, the star. As a result, the core of the star collapses. As it collapses, a giant shock wave is generated. The outer layers of the stars are thrown out at very high velocity, and the core of the star collapses and becomes either a neutron star or a black hole. If the mass is less than about 3 times the mass of the sun, then it becomes a neutron star, otherwise it becomes a black hole. So that is how white dwarf neutron stars and black holes are formed. So white dwarf neutron star and black holes are really the end point of what we know in astronomy is stellar evolution. Okay, so neutron star and black holes are reincarnation of the original star. Next slide, please.